of Agriculture, Shri Vaishno Vidyapeeth Vishwavidyalaya, Indore. Co-chairperson Professor M.P. Gautam, Shri Vaishno Institute of Forensic Science, Shri Vaishno Vidyapeeth Vishwavidyalaya, Indore. Our speakers, Dr. Vijay Kumar Rajdan, ex-professor and head division of plant pathology, SK University of Agriculture Sciences and Technology of Jammu, Chhata, Jammu, and Dr. Tilip, ex-registrar, professor and head Department of Agronomy, chief scientist and head FSR Center. I, Chavi Tiwari, feel privileged to welcome you all in the Agriculture Symposium in the Sanmantrana 2021, a multidisciplinary international congress on good practices and capacity building for sustainable development goals. Now I am handing over the session to Dr. Yuvraj Shinde to introduce our today's speaker. Yuvraj Shinde.
Hello, good afternoon to all. Can you hear me, sir? Yeah. Okay, sir. Today, in our agriculture symposium, I'm Yuvraj Shinde from Sri Vaishno Institute of Agriculture, and I'm here to introduce our today's speakers. We have two speakers, that's eminent speakers for today's symposium. Our first speaker is Dr. Vijay Kumar Rajdan, sir. He's an ex-professor and head Division of Plant Pathology, Sher Kashmir University of Agricultural Sciences and Technology of Jammu, Chhata, Jammu. In 1979, he joined the Department of Horticulture, Jammu and Kashmir, after qualifying the State Public Service Commission examination. In 1982, he joined SK University of Agriculture Science and Technology, Jammu and Kashmir, at main campus, Shalimar, Kashmir. In 1998, subsequently joined the newly created Sher Kashmir University of Agricultural Sciences and Technology of Jammu. And in 2019, he retired as a professor and head Division of Plant Pathology, Sher Kashmir University of Agricultural Sciences and Technology of Jammu, Chhata, Jammu. He served for 34 years as an assistant professor, associate professor, and professor of plant pathology. He is a life member of several scientific societies having more than 125 publications. He is a fellow of Indian Phytopathological Society. He handled 15 research projects funded both by the university as well as by the externally funding agencies like ICR, DPT, NAIBM, etc. He is guided several PhD and MSc research students. Also, he served as the member of university governance and university librarian for several years. Our next speaker is, we have two speakers, I have told really. We have next speaker is Dr. Tilip Kachru, sir. He is an ex-professor, ex-registrar and the head Department of Agronomy and former chief scientist, Farming System Research Center as and research administrator. He served as agricultural researcher, academician in various capacities for last 30 years in Sher Kashmir University of Agriculture Science and Technology, Jammu. A doctorate degree of Dr. Tilip Kachru, sir, in agronomy from JP Pant Agriculture University and Technology, Pantnagar, specialized in farming system research, nutrient and water management, crop production and weed management. He developed numerous production technologies which are in the farmer's practice, developed various production models of which integrated farming system model has been awarded by Indian Council of Agriculture Research as one of the best model in the country. He also developed 20 success stories at the farmer's field and acted as change agent. He is a person with full academic credential with 60 research publications, 3 books, and guided 6 PhD students with cutting-edge research. Presently, Dr. Kachru is a consultant to Sher Kashmir University of Agriculture Science and Technology, Jammu. And he is a member of Agri-Entrepreneurship Development Society. So I warmly welcome Dr. Tilip Kachru and Dr. Vijay Rajdan, sir, for today's session. Now, I'm handing over the session to Dr. Chavi Tiwari for giving brief introduction of our today's chairperson and co-chairperson. Dr. Chavi Tiwari, please.
Thank you, Dr. Shinde. I feel honor of giving brief introduction of Professor Vinod Dhar. Presently, he is professor and head Center for Vocational Studies, Shri Vaishno Institute of Agriculture, Shri Vaishno Vidyapeeth Vishwavidyalaya, Indore. He got appointed through Jammu and Kashmir State Public Service Commission in J&K State Government Agriculture Production Department in 1981. He worked there for about 37 years in various capacities. Possesses experience in agriculture extension, services, seed processing, frontline field demonstration, law enforcement, soil survey, soil testing, fertilizer testing, teaching vocational courses, administration, monitoring, execution of centrally and state-sponsored scheme for the welfare of farming community. He retired on superannuation as Chief Agriculture Officer in February 2018. Since December 2018, he is teaching undergraduate students of agriculture and monitoring the vocational activities in Shri Vaishno Institute of Agriculture, Indore, Madhya Pradesh. Now, I feel honor of giving brief introduction of Dr. MP Gautam. Dr. MP Gautam, after completion of his PhD, he started his career in year 1972 as an assistant professor in University of Sagar. Dr. Gautam joined Madhya Pradesh State Forensic Lab Sagar in year 1976 and held various prestigious positions like Joint Director and Director. He is the founder of Director of State Forensic Science Laboratory Raipur, Chhattisgarh. Apart from this, Dr. Gautam has also established Department of Forensic Science in Guru Ghasidas Central University, Bilaspur, Chhattisgarh. He served 36 years in Forensic Science Laboratories of Madhya Pradesh and Chhattisgarh. He has been the chemical examiner to the government of Chhattisgarh and assistant chemical examiner to the government of Madhya Pradesh and has submitted thousands of forensic reports to the Honorable Court and also appeared as government scientific expert in many session trials. For his perseverance and dedication, Dr. Gautam has been awarded with numerous awards like Union Home Minister's Award for Excellence Service in Forensic Chemical Science in 2004 from Ministry of Home Affairs, Government of India, and Director's Excellence Award by the Ministry of Home Affairs in 2005. He has been conferred with the Lifetime Achievement Award by the Indian Academy of Forensic Science, Kolkata in 2012. Now, I am handing over the session to the chairperson, Professor Vinod Dhar sir. Sir, please.
Thank you, Shavi. And good afternoon, all. I extend my hearty welcome to our guest speakers, Dr. Vijay Kumar Razan and Dr. Tilip Kachru, to this symposium on sustainable agriculture, which is held under Sanmantrana 2021. Sanmantrana is a multidisciplinary international congress, and the theme of this year's theme is good practices and capacity building for sustainable goals. In present day scenario, agriculture is confronted with various threats of shrinking land and water resources, also ecological and environmental vagaries, climate change, and still we have to grow in abundance and feed quality food to ever-growing human and animal population. One of the most challenging threats is of enhanced greenhouse effect, which in turn leads to climate change, global warming. One of the The problem we now face is that human activities, particularly burning fossil fuels like coal, oil, and natural gases, agriculture, that is farming, and land clearing, that's deforestation or for urbanization, are increasing the concentrations of greenhouse gases, which result in global warming and climate change. As you know, major contributors to greenhouse gases are factories, automobiles, deforestation, etc. The greenhouse never let the radiations to escape from the Earth's surface and increase surface temperature of the Earth. So, to sustain agriculture for our future generations, also, we have to exercise resilience and go for eco-friendly cultivation. We have to avoid excessive, indiscriminate use of chemical fertilizer, pesticides. And on the positive note, we can use crop improvement tools for better production. We can use organic biodynamic preparations for maintaining the health of the soil, for nurturing the crop production. We can use integrated nutrient, disease, and pest management practices to avoid residual effect on humans and animal population. In the same line, we also need to encourage and empower rural communities of services and promoting digital literacy in them. We also now have various mobile applications give weather and cultural practices related messages, and also e-commerce application which provide the latest commodity and mandi prices. So with these words, if Dr. Razdan is not visible on the screen, if he has joined, I hand over the session to Dr. Razdan if he is online. Dr. Razdan. Well, Dr. Tilip Kachru, sir, please deliver your lecture, sir.
Okay. Good afternoon to everybody, rather good evening. Respected today's chairman, Professor Vinod, Dr. MP Gautam, our co-chairman, and other honorable and distinguished gathering over here. So let me first of all extend my thanks for giving me some time to deliver the lecture on the very burning issues, whatever that Professor Vinod has highlighted. These are one of the very important burning issues nowadays which are confronting agriculture. So to begin with, once I got in that intimation, so I was gladly agreed to throw whatever my experiences I had. I had worked in the total agriculture system all throughout my career. And then actually, I had a call from your center, so I was attending it. So today's the topic
सर अनम्यूट कर दिया आपने, म्यूट कर दीजिए सर, इसको अनम्यूट कर दीजिए सर, म्यूट कर दिया है। काचरू सर, डॉक्टर काचरू सर।
ठीक।
हाँ।
हेलो हेलो।
हाँ सर, बिल्कुल बिल्कुल।
हाँ हाँ हाँ, मैं वही देख रहा हूँ। नाउ आई एम ऑडिबल ना?
यस यस, बिल्कुल बिल्कुल ऑडिबल।
विजिबल आल्सो, दैट्स ओके। ओके ओके, दैट्स इट।
अभी इनका चलेगा।
Some technical hiccup, Dr. Chavi?
Yes.
Some problem arising?
No,
No, sir.
no problem from here. Sir, you did mute from your side.
Oh, Chavi, this is
Mine is
Dr.
not mute.
Rajasthan speaking.
Okay.
Yes.
Okay.
Please, you decide who is giving the lecture, because Dr. Deep Kachru had started and now
Yes, he will continue, sir. He will continue.
Dr. Kachru will continue.
I will ask him to unmute.
Yeah, he has to unmute then.
हाँ, ये अनम्यूट कर लो आप, ये म्यूट है। फिर डॉक्टर राजान कंटिन्यू करें, स्टार्ट करें? ठीक है, ओके। डॉक्टर राजस्थान, आप स्टार्ट कर लीजिए सर, प्लीज गो अहेड।
Okay. Then I will have to share the screen also with you regarding my presentation. Okay. First of all, good afternoon to all of you. I really particularly to chairpersons Dr. Vinod Dhar and Dr. MP Gautam, and the reporters Dr. Chavi Tiwari and Dr. Yuvraj Shinde. I appreciate the opportunity that has been provided to me by your university to share with you some thoughts regarding the integrated disease management, which is an important part of the sustainable agriculture. For my presentation, I would like to share my this presentation screen with you. So for that, please, I'm going to the screen, the presentation one. मैं शेयर करना चाहता हूँ स्क्रीन आपके
हाँ सर, बिल्कुल शेयर कर लीजिए सर स्क्रीन।
नहीं आ रहा।
सर जी, यहाँ पे मैं शेयर कर लूँ आपकी स्क्रीन, तो आप सिर्फ प्लीज। सर क्या आप देख पा रहे हैं?
हाँ जी, आप क्लिक कीजिए आप उस पर।
Yes, yes, sir. You can start. You can start. Yes.
क्लिक कीजिए आप।
So now screen is visible, sir.
Your screen is visible. You click on the presentation part.
Yes, this presentation part. This is.
Now it has not come to my screen. Only your screen is visible to me.
Presentation is not visible yet.
Presentation is not visible.
Present is not visible. Your screen is visible, of course.
Okay, okay. शादाब सर, ये presentation visual कर रहा है ना? ये presentation इंदौर का. ये.
Otherwise, you can guide me how I can open my.
Yes, sir. नहीं, वो है सर यहाँ पे. 1 minute.
अच्छा.
Yes. Share screen. Sir,
yes, it's visible now.
Yes.
Yes. Now it's visible. Now it is visible. Okay. Should start now?
Please,
Okay.
please do start, please.
Yes, sir.
Sir,
Go
please
ahead.
start. Please start.
Okay.
Please start.
Okay. Okay. Then just a minute. So these are the teething problems that we are facing with this webinar. Now, all of us are new to this. So we have to bear with each other the inconvenience that has been caused from your side, from my side. And nevertheless, let me start with the integrated disease management, which is a very important aspect as far as the sustainable agriculture is concerned. And the next slide, please. Each time I have to ask you for changing the slide, I think. Yeah. As far as the sustainable agriculture is concerned, it is the farming in sustainable way, meeting the society's present food needs without compromising the ability for current and future generations to meet their needs. It's basically based upon the ecological or the ecosystem which is prevailing at this time. Just before going further, I will just like to highlight some of the important data regarding the world scenario vis-a-vis to the back one, the previous one. This one. The India. As far as India is concerned, it's the 6th largest economy as far as the nominal GDP is concerned, and the 3rd largest as far as the purchasing power parity is concerned, which is shortly called as the PPP. And this is a very rosy picture as far as India is concerned, but at the same time, there is something which is of concern, and that is regarding the ranking of India, which is 139th as per the per capita GDP is concerned, and 122 as per the GDP PPP is concerned. So this is something a very gloomy situation, but nevertheless, agriculture accounts for about 23% of our national GDP, whereas it employs 59% of the country's total workforce, which is an encouraging sign. And fortunately, our country is bestowed with the vast agroecological diversity. With the result, number of crops are grown here, and it's also suitable for various types of livestock also. As far as India is concerned, it is the world's largest producer of milk, pulses, and jute, and second largest producer of rice, wheat, sugarcane, groundnut, cotton, horticulture crops like vegetables and fruits, and it's the leading producer of the spices, fish, poultry, livestock, and plantation crops. And agriculture production values about $400 billion. And this is something very good because it is much more than that of US, which is around 280 billion. Next slide, please. And but the Indian economy is diversifying. This is a good sign because the industries are coming up right from the after 1950s, early 1950s. The industrial revolution, to some way, with small steps, has taken place in India also. With this result, the agriculture's contribution to GDP of national GDP is declining. Although we have achieved food sufficiency in our country, but again, the gloomy picture is that the India accounts for a quarter of the world's hungry people, and also home of about 190 million unnourished or malnourished people. As per the Global Nutritional Report is concerned, India ranks about 114 in the world, and that is, and also as per the prevalence of anemia is concerned, it is 117. And you can see that there are only 15 countries which are below India. So this is again a very dark situation as far as the Indian uh, productivity and the malnutrition is concerned. The anemia is affecting 50% of women, which include the pregnant women also, and about 60% of the children are affected with the anemia. Next slide, please. Next slide, please. So for this, sustainably improving the agriculture productivity to meet the increasing food consumption of the need is very important. In 2050, India's population is going to be around 1.7 billion, and it's a huge population. At that time, it will be highest in the world, more than about 400 million, more than that of China. And to meet this demand, the land productivity has to be increased by 4 times. And this is all the more important because the population is ever growing, urbanization is taking place at rampant speed, and with the surge of middle income group, the per capita income of the people are also is increasing. They have got more purchasing power. Therefore, we need to have more food for them. And at the same time, the natural resource base upon which agriculture depends is becoming stressed over a period of time. And at the same time, again, the climate change is showing its effect. And it is presumed that beyond 2030, adverse impacts will be significantly visible and in most part of the world. And along with it will be associated with extreme events like droughts and floods, which will be becoming more frequent. And climate change will be responsible for number of production related emergencies throughout the world. And to meet this challenge, the government of the present day is coming up with a number of plans regarding the doubling the farmers' income in order to sustain the farming community. Because as you know that the farming systems in India is such that their land holdings is very less in majority of the farmers. So in order to have them economic strength, doubling the farming income and sustaining the food and nutritional security, integrated approach is very important. And this integrated approach has to be associated with number of agriculture sectors, various agriculture sectors, not only to be, we have to focus only towards the field crops. Because at present, our more focus is towards the field crops only, but whereas horticultural crops like vegetables and fruits are equally important, and then forestry, livestock, fisheries, and very important aspect which is coming for the modern days is that of processing engineering. So we have to focus all of them in order to have an integrated approach in order to doubling the farmer's income. Next slide, please. I have given just a brief data regarding how, what is the projected this production and what is the present production. As far as the food grains are concerned, you can see that food grain, we have to have a quantum jump. We need it. Pulses, we have to double our production. And the cereals also, we need a good jump. Vegetable oils, equally good jump. And vegetables, it has to go double. And the fruit crops 3 times in order to meet our requirement in the future. Next slide, please. This is indeed a very challenging task, and sufficient food production is one of the main challenges for the mankind Currently, about 800 million people are suffering from the hunger. Among them, there are children below the age of 5, and it trends for the near future for a negative growth, particularly for those which are developing countries, where the population is increasing at a very fast rate, and at the same time, the land degradation is continuing. And this land degradation is various types. And under these circumstances, by 2025, the cereal production has to be increased by nearly 40% to meet these demands. And this is a very sad story, because we have to depend on the intensive agriculture. Intensive agriculture has given us very good fruits. As far as the Green Revolution we can see in the past, in late 60s and 70s, Green Revolution has given a very good results for our country, making us self-sufficient. But at the one hand, if it has enhanced the productivity of the crop, but it at the other hand, number of diseases, pests, and weeds have come up. They have been associated with this intensive agriculture, and more we have become dependent on the chemical pesticide, use of chemical pesticides. And this use of chemical pesticide, or overuse or non-judicious use of chemical pesticides, is not going in hand with the sustainable agriculture. But nevertheless, the future is coming for the dominance in the plant production scene. In order to maintain the genetic and to achieve the genetic ability of the crops or different varieties, we have to protect them and give them a good protection, so that we are able to harvest the good crop. Next slide, please. So the agriculture at present is facing with increasing number and intensity or incidence of diseases and pests. And it is important to control these diseases in order to reduce the yield losses and boost our productivity. Moreover, plant disease management determines the effectiveness of other inputs, very important inputs like seed, good quality seed, fertilizer, and water, so that we have good production. The negative side effect of this intensive use of chemicals is well known, because it is very much visible as far as the pollution in the environment, soil and water is concerned. Therefore, to minimize the use of chemicals, the only alternative is going for the integrated disease management, which is the only right approach. Next slide, please. Next slide, please. To understand the disease management, first we have to understand how the disease occurs. It's a virulent pathogen, a susceptible host, and conducive environment. If all these three are there together at one particular point, then only disease occurs. And environment, we don't have much control, because that's the natural phenomena. Whereas we can manage only the micro environment, that is the canopy management, by which we can reduce the diseases. But two things that we can manipulate, and that is the pathogen and the host. The management of the pathogen is basically how we can reduce the pathogen population in a particular field, and host management is how resistant varieties we can provide to the farmer, which is the very cheap method or very inexpensive method as far as the farmer is concerned. These are the two things, pathogen and the host, which we can manipulate very easily. Next, please. So the key, previous one. Those are key effective disease management. There are two aspects. One is the correct diagnosis. This is the very important thing. First, we must diagnose the disease, then only we can have a management, and that an integrated disease management system. In order to have the correct diagnosis, next slide, please. We must first understand, next slide, please. We must, previous one. We must first, the previous one. We must first understand what is the cause of the disease. This is very important, whether it is due to some living organism or non-living. That is, whether it is an abiotic or biotic. Among the abiotic factors, which are non-infectious, basically, that can be adverse climatic conditions. That means, say, for example, if there is a hailstorm, it will cause a lot of damage to the crop. If there is too much of rains, too much of snow or freezing, that will cause disease in the plants, or the chemical injuries. There are different types of chemical injuries. Say, for example, if the rate of pesticides, the pesticide concentration is not conducive, it is too much toxic, that will cause the disease, injuries to the plant. And moreover, if the weedicide at the higher concentration rate is given or applied, that will also cause the problem to the plants. And atmospheric impurities like sulfur dioxide concentration or the carbon dioxide concentration in the atmosphere, it causes these problems, the disease in the plants. And adverse soil conditions like deficiency of particular micronutrient or nutrient, or toxicity of the nutrients, that they will cause the symptoms and the disease. Among the animate cause or the disease causing agents, which are the living disease causing which are the infectious diseases like caused by fungi, bacteria, viruses, nematodes, and so many other things. So we must have a clear understanding what are the cause of the disease, so that we can go in for an effective disease management strategies. And next slide, please. So it is critical for making a correct disease management decision in order to save our money, time, and environment. So for example, if a disease is caused by the deficiency, the yellowing of the plant will be there. And if the farmer goes and sprays the pesticide or the fungicide, it will just be waste of his time, money, as well as will cause pollution to the environment. So it is very important. And effective use of fungicides and other pesticides also depends upon the identification of the problem. Otherwise, we will be unnecessarily going for the application of fungicides or other pesticides to the farm, and make already the resource scarcity is there to the farmers, and adding to the problems to these farmers. And it is important to know the common diseases which are prevalent in that particular area, and what are the common pathogens which are prevalent to the area, so that it's easy to make a decision which fungicide or which pesticide or insecticide we are going to apply in that particular field. We can also take the help of plant disease clinics, which can help us in the identifying the particular problem and making us wise regarding strategizing our disease management program. Next slide, please. Next, please. So again, in this aspect, the monitoring is a very critical component as far as the integrated disease management program is concerned. And this monitoring can be done by two methods. One is direct method, and another is indirect method. As far as the direct method is concerned, direct method is just looking upon the pathogen or the diseases which are prevalent. And based upon that, we can optimize the disease management program. Say, for example, we can avoid the low-lying areas, or those areas where there is lush green growth. There we can go in for seeing these pathogens, or we can take the samples from those areas. And at the same time, it's important to understand the biology of the disease and appropriate sampling strategies. Because if it is a seed-borne disease, the first diseases that will be visible in the field will be uniformly distributed throughout the field. Whereas if it is a soil-borne disease, then in the field there will be patches of these diseased plants. So it is easy to understand that whether it is a soil-borne disease or a seed-borne disease. Whereas if it is transmitted by the insects, the insects are playing a role of vectors, then the disease will be randomly distributed throughout the plant, throughout the field, or it will be at the margins of the field. Because these vectors will be coming from other fields. So more will be on the margins or on the edges of the field, and also randomly distributed throughout the field. Whereas the indirect method is based on the environmental conditions, and for that, disease forecasting system is very important. Through the disease forecasting system, we can understand at what time the disease will be coming, and what will be the magnitude of the disease, what will be the severity of the disease. So accordingly, we can have our strategies set for the management program. Next slide, please. And in order to have a disease management program as such, there are three basic principles for disease management. One is avoidance. Avoidance as such means preventing the contact between the host and the pathogen. And this contact between the host and pathogen can be avoided by selecting a proper geographical area where the disease is less, and then selection of proper field. Selection of proper field means that we have to understand if there is any history of the disease. If there is any history, particularly for the soil-borne disease, if there is any history of that disease prevalent in that particular field, we must avoid that field. And the field should be having proper drainage system. There should be no water logging in those areas. And particularly for the perennial crops, like horticultural crops, we must see the soil compactness. We must ensure that there is no hard pan beneath the soil. Otherwise, after 10 or 15 years, or after 5 or 10 years, we can understand. We will come to know that the whole exercise has been wasted. So these are the some points while we can avoid the contact between the host and pathogen. Moreover, the choice of planting time also, we can alter the date of sowing, early or late, so that the contact between the susceptible stage of the plant and the virulent phase of the pathogen is avoided. And also proper selection of the seed or transplanting material should be there, so that they are free from any disease. Next point is exclusion. This exclusion is preventing the entry of a pathogen in a field or area which is supposed to be free from any pathogen. This exclusion is majorly done by quarantine regulations, which are set in different countries or different locations, different areas. And this quarantine is by different entry points. These entry points can be at the airports, at the seaports, or the land borders. And if there is suspected that the material is having any disease problem, it's kept under quarantine for a specific period, and so that the inoculum does not come into the area which is supposedly be free from the disease. Inspection and certification is carried out particularly for those crops which are used for the seed production, so that we grow healthy seed, disease-free seed, and that is one way of excluding the pathogen. Exclusion can also be done by seed treatment or the eradication of the vectors which are carrying the viruses from one place to another. The third principle is eradication. By eradication, it aims at removal of the inoculum already present in the field or in the crop, and reduce the inoculum density wherever it is possible. It can be done by using biological control agents, or by crop rotation, or eradication of the diseased plants and plant organs from the field. And also it can be done by physical treatment, that is heat treatment, or by the chemical treatments. In the field, by flooding also, we can eradicate the pathogens which are present in the soil, or soil solarization, which is a very effective method, particularly for the seed beds. The soil solarization has been very effective, and particularly Israel has taken very good steps, and large-scale soil solarization is done in that country, and to the very good effect. But if the pathogen is coming by air from one area to another area, so avoidance, exclusion, and eradication will not be that effective. These three are very effective if the pathogen is soil-borne or it is transmitted by seed. But for airborne diseases, the most effective method is protection. By protection, we mean that preventing the contact between the host and the pathogen by creating a toxic barrier between the two surfaces. And this protection is provided by the chemical sprays or dust or seed treatment. And apart from the chemical applications, the best method of protection is the cultural practices. By cultural practices means there are which modify the environment, and like improving the aeration under the crop canopy, and reducing the humidity in the crop, irrigation, managing the irrigation and fertilizer, that means nutrition management as well as the irrigation management is very important for protecting a crop from the pathogen. And third one, the fifth one is a resistance, that is preventing or reducing the infection by genetic manipulation. This genetic manipulation can be done by hybridization, which is a very common method. And apart from that, by various biotechnological tools, we have our genetic engineering, by which the creation of transgenic plants can be done, which are very resistant to different types of biotic factors. So again, I will stress upon this thing that as far as the farmer is concerned, if he is having a resistant variety, that is very good for him, because he has not to bother about other management practices, only to sustain the resistance or keep the resistance for a longer period. He has to go in for minor spraying or other management practices. The last one and the sixth one is the therapy, which is curing the infected plant part. As far as the curing of infected plant parts is concerned, in the plants, if the leaf is infected or showing the symptom, it cannot be cured. That the tissue which is infected cannot be cured. Only thing is that the severity can be reduced. And therapy is achieved by different systemic fungicides and antibiotics, which go into the system of the plant and cures the tissue from the invading pathogen. Next slide, please. Now, if we are considering that integrated disease management is the only alternative, then why we must go for integrated disease management? The reason is that if we depend more on the chemical fungicides, it results in the pathogen resistance. The pathogens become resistant against that particular fungicide over a period of time. And moreover, because of the stress or the selection pressure, the new pathotype strains develop, and to control them is very difficult. Moreover, there are residual effects in the produce, whether it is the fruit, vegetable, or the cereals. And to cap them off all, the environmental pollution is there, which is again causing a lot of problem. This has led to the development of integrated plant protection system, which is an important component of sustainable agriculture with a sound ecological base. And the IDM aims at prevention and reduction of the incidence and severity of the disease and the pathogen, so as to keep the damage or loss below the economic threshold level. The basic objectives of IDM, or the integrated disease management, is to reduce the introduction of disease into the crop and to avoid the conditions that are suitable for the disease establishment and its spread. Next slide, please. The previous one. The IDM involves the need-based use of pesticide only, which I have been stressing, and that's why I have shown the previous slides that there are 6 basic methods by which the principles by which the disease can be managed, and not only to be dependent on the chemical pesticides. Only need-based use of pesticides should be there, and this is a greener alternative to the conventional use of chemicals only, and we must go in for the most effective combination as far as the farming is concerned, where the judicious use of all the concepts or all the principles of disease management are employed. In other words, IDM program implies in all the available management approaches, including the cultural, biological, and physical controls or the chemical control, with the main objective to keep the disease incidence below the economic threshold level. Next, please. Now I come to the IDM methods. The IDM method has not to be started at randomly, but it has to go step by step. Step by step, I mean that first the site selection and the preparation of the land. And for that, we have to see, as I have earlier also said, that we have to see that before selecting a particular site, we have to go in for see the history. What is the history behind that particular site? If there is any history of soil-borne diseases, and we must go in to start with clean soil and proper site selection for a particular crop. Ploughing, deep ploughing is very effective. Although fallowing is also important, but no farmer will go in for the fallowing because no farmer would like to keep his land vacant for a period of time in these particular days. The soil solarization and biological control is very important in order to eliminate or reduce the initial inoculum from the field. And soil compactness should also be avoided in order to promote good root growth. So bed preparation is very important. Plant density should be optimum. Canopy management in order to give good aeration to the crop or the canopy is very important, so that we have good aeration as well as there is good optimum pesticide coverage to the plants. Raised beds are considered good, particularly for the vegetable crops. And as far as the saffron is concerned, which is a very economically very huge this money earner, for that also raised beds are considered good because they provide better drainage. And before going for the sowing of the crop, soil testing is very important. Soil testing for the nutrients also, to see the nutrient level as well as for the disease pathogens, particularly nematodes. Next, please. After selecting the site, now we have to select the variety, which should be an appropriate one, having good resistance against a particular disease which is prevalent in that area. Particularly, those cultivars should be selected which have multiple pathogen resistance. And the strategy for using resistance is for gene pyramiding, which involves the use of several genes in a single cultivar, which provides wider base for the resistance against different types of strains of particular pathogen. And gene deployment is also very important. The use of different combinations of resistant genes in a different area of an epidemiological zones is a very important strategy. That means we should not depend on one mega variety. We should not depend on one particular variety in a huge epidemiological zone, but different varieties having different levels of resistance should be used, not depend on one mega variety. Then cultivar mixtures and multi-lines should be used in order to prolong the resistance against a particular disease. Next, please. Then comes two important management factors. One is irrigation, another is nutrition. First, I will take the irrigation management. And the irrigation system should minimize the leaf wetness. And you see, these days the flooding system has gone. Irrigation management is based on plant need only nowadays, which helps to create an environment which is unfavorable for pathogen survival and disease development. And wherever it is possible, now we go in for, or we advocate the sprinkling irrigation or the dip irrigation, so that high soil moisture is not there, because if there is more soil moisture, then the diseases caused by Phytophthora, Pythium or wilt is more there. Soil-borne diseases are more. Excess water also damages the roots by depriving them of oxygen and making them more prone to the pathogen infections. And we must always avoid the low-lying areas as far as the disease management is concerned. Next. Next, please. Next slide, please. And the soil and fertilizer management, the fertilizer program, again, it should result in optimum plant growth. Now, because if we measure nutrients like NPK, we will see that Indian farmers are more tilted towards the use of nitrogen and less of P and K, phosphorus and potassium, which is wrong. Because if there is more of nitrogen fertilizers are provided, then there will be more of vegetative growth, and vegetative growth will then attract more of pathogens and cause more of diseases in the plants. So plant nutrition and soil pH is very important and have got their impact on some diseases. We have seen that increasing the soil pH by liming is a good management practice to reduce the fusarium wilt as well as botrytis gray mold severity. And same is true with the calcium nutrition. If the optimum calcium is produced, it will reduce the bacterial wilt incidence as well as minimize the blossom and rot and provide more healthy growth to the plant. So next, please. Now we come to a very important aspect, and which is very integral part of IDM, integrated disease management, that is use of biological control agents. Because biocontrol, it plays a very crucial role in regulating the pathogen population in a particular agro ecosystem. And using these biocontrol agents for disease management is increasing day by day, particularly in the organic farming. Because as you know that the organic farming is an in thing now, and people are opting for the organic farming. And biological control agents are safer also for environment, as well as to the applicator who is applying these biological control agents. And they are very effective for the soil-borne, against the soil-borne diseases. And these biological control agents belong to the fungi, bacteria, actinomycetes, and there are several bacteriophages also which are used against the virus. Next, please. Yeah, here, just 1 minute. I would like to, you can just have a look at the photographs that I have attached with it. See how a fungus, a trichoderma here, is coiling around the nematode. That is the first one, coiling on the left side. Yes, it is coiling around the nematode and strangling it to the death. Similarly, it is coiling around here. Here, the next one I am showing you here is around the. This is the trichoderma. It is coiling around the pythium mycelium, causing holes. This is just on the right, next photograph, causing the holes are puncturing the this mycelium, and so that all the cell organelles coming out of it. There is a complete leaching of these cell organelles and causing death to the mycelium or to the pathogen. This is a very important way of disease management, this biological control. Next slide, please. Now there are different types by which these biological control agents are working. Like here, I have shown some, the direct antagonism, which is by hyperparasitism or predation. Like Abromyces piscalis is one example that I have cited here, and another one is of trichoderma, whether it is trichoderma viridi, virens, or argianum. They are all very effective biological control agents, and this is the direct antagonism. Then next one is mixed path antagonism. That is by producing and by way of antibiosis. By antibiosis, we mean by producing certain antibiotics. These biological control agents give rise to certain antibiotics which cause death to the pathogens. And similarly, there are certain lytic enzymes and unregulated waste products like ammonia, carbon dioxide, and hydrogen cyanide, which is produced, which is deleterious to the pathogen. Third one is indirect antagonism, where there is no direct relationship between the pathogen and the biological control agent. It is basically based on the competition. And this competition is for nutrition as well as for space. Moreover, these biological control agents, which are very commonly used, they have got the side, they produce cytophores, and these cytophores, they act as chelating agents for a very important micronutrient, that's iron, making the pathogens, depriving the pathogens of these iron ions and causing death to the these pathogens. And then these biological control agents also, they help in systemic acquired resistance or induced systemic resistance, by which the host becomes resistant against these pathogens. And there are a number of examples, whether they are pseudomonads, they are bacilli, there are this various strains and species of trichoderma, which are excellent biological control agents. Next, please. Next slide, please. Then we come to the last few slides, and in this I will show first the cultural practices. These cultural practices are very important, and if we concentrate more on cultural practices, I think there is very less need of these chemical fungicides, because they play an important role in prevention and management of plant diseases. And by cultural practices, we mean to establish a growing environment that favors the crop over the pathogen. And in this, the basic aspect is field sanitation. This field sanitation is aimed at excluding, reducing, and eliminating the pathogen population from the field. And it can be done by various methods that already I have explained, like solarization, use of biological control and others. And then use of pathogen-free seed and transplants, particularly like in viral diseases, avoiding the movement of the soil from one area to another, because you see the number of sclerotia by pathogens like Sclerotinia, Sclerotium, or Sclerotium rallopsi. These sclerotia move from one field to another, or one area to another along with the soil. Then also, in order to reduce the dispersal of soil-borne pathogen, we must decontaminate all the farm equipments, and removal of culled piles from the farm field, and destruction of the crop residues is very important. The transplant program should be such that it minimizes the transplant shock to the plant, and effective disease and pest monitoring is very important during the season. Next slide. Continuing with the cultural practices, a harvest and transportation procedure should be such that which maximizes the shelf life, and as well as it minimizes the wounds during the harvest and packing, which reduces the post-harvest diseases. Crop rotation is again not only very important for the disease management, but also very healthy crop also, and nutrition management in the field. Reduction of pathogen survival and primary inoculum by the destruction of weeds, voluntary plant, alternate and collateral hosts is very important. Even the stakes and the other the plant which are used for keeping the plant erect, they should be properly used so that there is proper canopy management and passage of air is there, wetness is reduced. And lastly, the organic amendments, which are also very farmyard, for example, use of farmyard manure and soil microorganisms, which help in giving a very good healthy crop and managing the disease also. Next, please. Then comes the chemical control. This is the last, that's why. Hello. This is an important component of disease management program, and it should be integrated with other appropriate methods. And for this, it is very important that we must know the mode of action of these fungicides. And basically, these fungicides are of two types. One is protectant fungicides, which are most of the fungicides which are available in the market this time. They form a protective layer on the host surface, like copper fungicides, mancozeb, sulfur fungicides, and then the systemic fungicides, which go inside the system of the plant and prevent the growth of pathogen inside the host tissue. But one thing to remember is that the chemicals must be used as per the recommended rates and application frequency. The rate of, that is the concentration, is very important in order to avoid the resistance that's usually caused against these chemicals. Next, please. Now, this is almost, we are coming to the end of this particular talk. And what are the advantages? Is all the sum up of all these slides that I have tried to exhibit here. First is that by the IDM, we are ensuring the healthy plants, and it is a bio-based disease management alternative. It reduces the environmental risk and also reduces the potential. It reduces the potential environmental contamination. It also protects the non-target species. Most of these non-target species are basically the biological control agents and friendly microorganisms which are present in the soil rhizosphere. And also it reduces the need for pesticide and fungicide use. It eliminates the issues related to pesticide residues, and it also decreases the workers and public exposure to the chemicals, and alleviates the concern which the public is having regarding the pest and pesticide related practices. And it maintains or it increases the cost effectiveness of disease management program. Next, please. Next slide, please. Now, coming to the conclusion, the integrated disease management is a disease control approach wherein all the management strategies are used in order to maintain uh, disease pressure and to the economic injuries threshold. It does not advocate a routine chemical application program, but promotes the integrated cultural, physical, biological, chemical approaches. The routine application of fungicide is not appropriate. So there are so many other ways by which we can minimize the dependence on the chemical fungicides. And IDM also has got the benefit that it is a better disease management program than depending upon an individual method, say for example, on chemicals. So in the end, I would say that it is the only sustainable way of managing plant diseases in order to minimize the use of chemicals in the agriculture, in order to have a better uh, uh, crop and better life also. With these words, I thank you all for the patient hearing and giving me this opportunity once again. I would say thanks a lot. Thank you.
Thank you very much, Dr. Razdan, for your enlightening lecture on IDM. Now I invite Dr. Tilip Kachru to kindly deliver his lecture. Dr. Kachru, are you
Can
online?
we have some queries on this if anybody has anything to ask? Dr. Vinodar, can we have some questions on this?
There are no questions, sir, from the students.
If
From
there are some,
others?
yeah.
I have a question, sir, regarding bioagents.
Right.
Though we are having rearing bioagents in the laboratories, but we rarely see them in the field. We don't use, the farmers don't use, even the bioagents don't reach the farmers to apply in their fields.
I think the particular agriculture agencies which are dealing with the extension activities, they have to be more proactive as far as making these biocontrol agents popular among the farming community. Because if you go down towards the south, say for example in Karnataka and other states, there this use of biological control agent is so frequent, and moreover the farmers, they are using it as a cottage industry to develop their biological control agents and using them in the field, because they are giving the excellent benefits. Not only because one thing I must tell you, that these biological control agents, not only they control the diseases, but they act as PGPRs. That PGPR, by that I mean the plant growth promoting rhizobacteria and plant growth promoting fungi. So they are not only giving the control, but they are also promoting the growth of the plant. So they are excellent. And if this is not very popular, it is failure on our part that we have not been able to make it much extensively available to the farmers. But nevertheless, it is picking up. And in near future, you will see that they will be at par with the chemical use as far as the world scenario is concerned.
Thank you. Thank you.
So I have a question.
Yeah, please.
May not be related directly with the plant diseases, but the data which you showed on increasing crop yields and crop productions and all. Recently, due to this farmers' agitation, we keep hearing that we already have excess of wheat and rice in states like Punjab and Haryana, and we cannot even store it properly. We cannot distribute it properly. And then on one hand, we have this problem, and on the other hand, we have the malnutrition also. So is our problem more on distribution and because they are advising Punjab and Haryana people to change the crop pattern?
Yeah, you have very rightly, you have just hit the nail at the very head, because this is exactly the problem that you have cited. That is that our priority has been more towards the wheat and rice, and at the cost of other agriculture productions like horticulture, that I mean fruit and vegetables, pulses and other things. And the scenario has come to this extent now, in particularly in Punjab and Haryana, that the farmer is getting the lowest price. They don't want to deviate from that, because whatever they are producing, government is purchasing from them. And that is mainly, I think, one of the aspects that why the farmers are so much agitated is that this is the set system in these two areas, in these two states, where wheat and rice is produced and the government is purchasing from that at a cost which is much higher than the market value. And so there is abundance of these particular grains, cereals, wheat and rice with the government stores. It is not properly being distributed because the market prices are not to that extent at which the government is purchasing it. That's why government wants that these multinationals and other private companies should come in, so that there is some diversification in the agricultural crop production system, and the farmers also gain from that, and it is also to some extent meeting the requirement of our country needs also.
Yeah, I want to get it clarified in this way, that what you had to put the question over here. You see that once we are talking about the MSP, this is the minimum support price. This is not a retail price. And this is the price on which the government procures back from the farmers. With respect to the malnutrition is concerned, yes, you are correct. The more government can give it to that, and what is the affordability of the government for that matter. And that is why now Dr. Rajdan had clearly that because it is only the Punjab and Haryana which they are getting this rice, wheat is basically the main staple crop which they are producing, and they are getting almost 80% of the procurement. Government is doing that. That is why they don't want to lose it, and there are certain other factors. There are some middlemen also who are taking at the lower price, or who are paying to the farmers loan, and then they are getting the land on the higher basis. There are so many things. It is a very complex issue. So
I also no, there is another point to this, that you see earlier this other states were probably growing less of wheat and rice, and now even the other states have picked up in their production of staple food. And that may be one of the reasons that what the government is procuring, others are not needing it probably.
Yeah. Yes.
There's a need. Actually, what is the problem? Where we are lacking?
Please put off your mic.
Actually, where we are lacking, because we don't have the storage facility that at panchayat level, at block level, so that the farmer can and so that he can avoid this, because it's a very there are post-harvest losses. Suppose if the farmer will store and then he will see the market. That is why these middlemen having all the facilities, and they are going and procuring those things from them, and then they are purchasing, selling it from the higher rate. So one thing is there are a lot many government procure through FCI, Food Corporation of India. They are procuring it, and then distribution, because we have seen that the various schemes government has introduced, that midday meals and all these things, it is going over there. But how much of the government will procure, because the production is more, and then the prices, we cannot increase the prices also, because we have to see the global market also. If the price will be more, that is why we are putting subsidies into it. Basically, this is the consumer-driven policy we are having. This is not then that farmer-driven policy. What are the subsidies we are given? This basically subsidies is to be given to the consumer.
Okay, thank you.
Thank you, Dr. If there are no other questions, are there any other questions also? Dr. Are there other questions? Dr. Dhar?
No, I don't think there are any questions. Thank you very much, Dr.
So nice of you.
So thank you very much, sir.
Thanks.
Now may I request Dr. Kachru to please present his lecture.
Okay, good evening, Professor Dar, chairman of today's this session, and Dr. MP Gautam, the deputy chairman of this session, Dr. K.N. Guruprasad, the dean, and my dear fellow panelists and all our distinguished gathering, which we are here and on this topic. I have been already talked to you. I'm delivering on a very important note. Dr. Razdan had covered and given the overall scenario of the integrated pest management, although whole of the agriculture is related with it. Once we will talk on the commodity-based rice, wheat, or we will talk on the farm as a unit. So here I'm dealing with the farming as a unit, where we can see that the different challenges present agriculture in India is facing. That some of the it was in the discussion that how we are going to improve our crop yields, double our crop yields, get more profits, as well as address the climatic issues. So climate agriculture smart system is to be brought in. All of the agriculture is on the on the land, and we are having different land holdings in India. The land holdings are very small, and for that matter, we have to meet the requirements what these small farmers have to do, and we have to properly manage this land use. Mr. Sinde, can you share the screen of that? What?
Yes, sir. Yes, sir.
Yeah, please.
So can you see?
Yeah.
Yeah. Okay.
So this topic I had chosen land use planning in farming system perspective towards climate smart agriculture and improving profitability and livelihood security of the small farms. As we know that the land use planning at a farm level, at a holders level, is very much important. Because we have seen that in the past, what is the problem in the agriculture? Because in 60s, we have seen that we have got a lot many, this green revolution we have seen, then the food production level has been stagnant. And then what in today's context that there is a lot of marketing prices, farmers are committing suicide and all these things. And then the urgent need is that in a small unit of land, how we are going to increase the production so that we can double the farmer's income, all as well as the problem presently is that our climate change. Professor Dar in his address had already given some outline for that how the greenhouse gases effect and what is the contribution of our in agriculture, how we are also contributing towards these greenhouse gases. So we will discuss in one by one, and then what the past I had a practical experience of working all this. I will share you some of the data and some of the experiences with this in this regard. Next, please. So once we will say that, we will come on the what are the concepts of the land use plan. As we already know that land use planning involves the allocation of land to different uses across landscape in a way to balance the economic, social, and environmental values. And the principal aim is towards productivity, security, protection, viable, and acceptability. So for that matter, this is very important. There are so many things, land use planning, there are certain imagery systems, satellite imagery system, and all these things. But once we will come at the particular at the farmer's level, farmer's field level, then the land use planning, what we have done it on the basis of the nutritional requirement of the farm family. So if the farm family is having, because everything relates nutritional requirement and the income and livelihood security. So with this model, I will more emphasis on the land use planning on the basis of the nutritional security. Next, please. Then comes the climate smart agriculture. Once we are talking about the climate smart agriculture, it's very important because it's an integrated approach to managing landscaping, cropland, livestock, forestry, fisheries, that addresses the interlinked challenges of food security and climate change. Because whatever the climate change we are seeing this time, there are unprecedented rains, or there are so many things which is happening, which is not collaborating with our agriculture calendar which we are having. And this climate smart agriculture is defined as agriculture practices that sustainably increases productivity and income, adapting, building resilience to climate change, and reduces the greenhouse emission. So with this concept, that now this is the concept with us, that how we are going to reduce the greenhouse emission, how we are going to double our productivity, and what are the ways that how we are going to efficiently use our land, which is one of the primary resource for our agriculture production. Next, please. So why landscaping approach in CSA? In climate smart agriculture? Climate smart agriculture practices the activities practices will be a part of landscaping and complete against the other land uses. So once we are talking about what are those climatic smart practices, we can see that it is an integrated renewable energy. What is the solar energy? All these things we have to integrate it, which are the renewable source. We are talking about the microorganisms and all these we have to brought into the picture. Then we have to diversify our activities. We have not to based on our only one component, rice or wheat. We have to divide our land into the different components, wherever we can see that how we can maintain the sustainability, how we can give, because a farming system approach, in a farming system approach, we have to think. What is a farming system approach? If we'll keep the farmer at the middle of the farm, and whatever activities he is doing, whether he is doing animal dairying, or he is involving in fishery, or he is involving in poultry rearing or mushroom cultivation, all these things, because these are very interrelated things. So we have to think in a direction so that we have to see what are the problems, and then we have to use the resource that conservation technologies. What are those resource conservation technologies? We have to see that we have to see wherever we have to go for the zero tillage or minimum disturbance of the land, because there are three guiding principles of resource conservation technologies. All the three guiding principles we have to induce into it. Then we have to see that in the crop rotations also we have to take into the mind. We have to also see that we have to diversify the crop. We have not to go for only rice, wheat. We have to diversify our cropping system, and then it is to be diversified in such a way so that because we have to bring certain. So there are certain C3 plants and C4 plants. C4 plants, they are having the dual fixation of the carbon dioxide. They remove carbon that from the atmosphere, so that forever then. We have to adopt such technologies. Then we have to use certain tolerant varieties, whether it is a pest tolerant, heat tolerant, drought tolerant, or salinity tolerant. Then adaptation and mitigation practices we have to brought in. Now you can argue with me that what are the adaptation and what are the mitigation techniques. Adaptation is that once we are having a short-term planning. Suppose if we are growing a crop and then some problem, weather aberration comes, and then we have to supplement it with our production system, and immediate measures we have to take it. Those are called as adaptation techniques. And then third technique is mitigation technique. It is a long process. Whatever the pollutant greenhouse gases are there, we have to remove it from the atmosphere. So that's called as carbon sequestration. So we have to adopt those in a cycle that our production system is such a way so that we can take care of all these things. And then there's a computer-aided that simulation models are there, and then there are certain information communication technologies are there. We have to use it, and then we have to integrate it with our production system. Next, please. Next, please. Then if we'll see that, because although we are saying that there is a lot of pollution, and this from agriculture point of view, we are also contributing a lot of towards this greenhouse emission. Suppose if we'll see that we are applying these nitrogenous fertilizers, or we are chemical fertilizers we are applying. So nitrous oxide, it goes into the atmosphere. Then nitrate leaching is there. It goes into the that it pollutes into our groundwater. Then there is the methane production is there, either from the rice cultivations or from the cattles, because we have got certain, I have quantified it, certain figures. Then biomass burning also, it also adds to this that greenhouse gas emission. And then rice production is there. and then manure. It also adds these carbon dioxide equivalent gases, because then irrigation, farm machinery, pesticides production, and land conversion to agriculture. So I can say that overall, we can say that it is carbon dioxide equivalent gases. I have put it like this: nitrate, main is nitrate, methane, and carbon dioxide. From these, from our agriculture practices, we are contributing it, and it's a very that 20% of reduction in the global areas of the forest during the last 140 years, realizing that 120 greenhouse these carbon to the atmosphere we are contributing. Next, please. So then what is the answer for all these things? Because we have to also see the solutions. We know the problems, we know that what we are doing. So we will adopt a farming system and practices approach, where we will take the holistic way, how we will modify all these things. And for that matter, we have designed a model which will take care not only about the conservation agriculture, agroforestry, all the diversified and integrated farming system, and an energy and food energy system into the system. Or whether it is from the horticulture, whether it's livestock production, efficiency and resilience, and fisheries and aquaculture. Next, please. So once we talk about the farming system approach, we will take a practical view of it. We will first give it that what's the farming system approach. Diversification and integration of activities in a farming system perspective means to introduce a change in the farming techniques for maximum production in the crop and other enterprises, and take care of optimal utilization of resources. It involves the intensification of agriculture activity and is focused on a few selected, independent, interrelated, and often interlinking production system based on crops, animals, and related farm enterprises. So this is very much important, because we have to think in an integrated approach, because if there is one enterprise, that is to be integrated with the other enterprises and in a sustainably, and so that we can reduce the cost of production in a unit form, as well as we will increase our profit also. Next, please. So there are certain basic informations. Before that, we will go for that. We have to see that basic informations, it should be with us. Once we are going to plan, we're making the land use planning or climate smart agriculture options, we have to go into adopt. We have to do, we should know the data of these alternate cropping systems which are existing in a particular area. What are the major prominent livestock, other complementary and supplementary enterprises which are suitable, diverse, because whole of the agriculture is it is location specific. And then wherever the location is there, accordingly we have to make our planning, all these things. Then horticulture crop, fisheries crops, wherever we are having the abundant water, we can go for the ponds and we can go for the fisheries. Then mushroom, apiary, vermicompost, farm waste recycling, which is one of the very much important, because this is the waste wealth. This adds a lot of income to the farmer in private. Then biogas, because if we will burn this methane and use make this, whatever the cow dung is there, a lot of this methane is coming from the cow dung or from the animals, because methane gas emission takes place. So we have to reduce it and we have to use it. We have to use it in the form of the fuel and then use in our cooking purposes. Then boundary plantation and perennial fodders are to be used, because if we have to sequester these pollutant gases from the atmosphere, then we have to plant certain plants which can trap these carbon dioxide into the system, and then we have to park it. So besides that, we should know in a particular area, if we are going to design in a farming system mode, if you are going to do this land use planning with respect to the climate smart agriculture, then we must know that what are the number of the farm holds, average land holding size, average farm family size, soil parameters with respect to what is the texture, water holding capacity, weather informations, predominant farming system of the area, farming situations, integrated rain-fed area, production, productivity, gross net return of each enterprise and their status. So then practices adopted by the farmers, and what are the constraints these are for getting the low income, grazing land area, feeding status of the animals, green fodder, concentrates and mineral mixture, present contribution by different components and nearby market. We have to look into the system. Then we can plan, we can do it, and we can correlate it with our objectives. Next, please. So as far as the land allocation is concerned, we suppose here I have worked on a 1 hectare of area where the land has been allotted to the certain commodities or the certain enterprises on the basis of the nutrition value, because on this taking the nutrition requirement for a 5-farmer family on an average as a base, and then accordingly that we have allotted to these areas. Suppose crop is there, crop because there is a crop means main field crop, either it is rice, wheat or maize, then it is around about 0.38 hectare we have to allocate it in a 1 hectare farm. Similarly, the fodder, which are the requirements for your animals, because without animal we cannot achieve to have the double, have to increase our profit or double the profit, double the farmer's income. So for that matter, 0.07 area is to be allotted for this particular in a 1 hectare. Then animal, which over a period of, this is my 10 years research data, which I am sharing with you. Animal, round about 0.08 area per hectare, we need it in a total hectare of 1 hectare. This is the one of the best and efficient land use planning. Then horticulture, 0.37 hectares, fishery 0.10 hectares, where there is a water bodies. Otherwise, we can go for the goatry to that area if that there's a water scarcity. So we have accordingly to see the situation. If it is the rain-fed ecosystem or if it is an irrigated ecosystem, accordingly we have to manage it. And then mushroom production also, which gives a subsistence income to the farmer. To increase this 0.02 hectare, we can allot this. And this is the best and efficient way. And this land use planning has been that validated. And for the last 10 years, the data has been some of which I'm going to share with you. So round about on an average, if we can see that we can give round about 36% area, 56% area on the crops, 27% area to horticulture, 6% area we can allot to fisheries, agroforestry, around about some 3% area, and dairy 7% area, poultry 9% area, and green fodder 6% area we can allot, and 2% for the mushroom. That way, this is the one of the most efficient land use planning which we did here on a farmer's holding. Next, please. So you can see that on these crop blocks where we have allotted, we have diversified our crops. We have not only, we have induced the green manuring, because we want to reduce the this fertilizer in order to reduce the greenhouse gases emission. We have induces the green manuring and reduces the chemical fertilizers. Then rice, potato, mash. Mash is also a legume. It also traps the atmospheric nitrogen into the system, and pulses are very much required, which you can see that it is the source of supplying the protein to the farmer's family. Then rice, mustard, and green gram. We need all of that farmer needs that oil seed crop, and its cake is also, it's having the multiple uses. It can be fed to these animals also. Then green gram also, again, it's the green gram is again a restorative crop. It also fixes this. It's a leguminous crop. So we have to make certain choices, because we have not to plant only those crops which can which can drain away all our nutrient source from the soil, but we have to replenish also. For that matter, then sorghum plus cowpea and berseem, and hybrid napiers on the bunds and dikes. This gives us a tremendous improvement once we are adopting such a diversifying our crop activities. Because even one of the question in the presentation of Dr. Razan came that why we are, he has also emphasized that we should not only give the rice wheat. That is the problem what is happening with the Punjab and Haryana. So we have to diversify our cropping system, because each and every component is very important. It's not only the one component. Then we have to already equally give to the horticulture crops, vegetables, which because there's a need and demand for that. And secondly, now on the basis of that, on the basis of the requirement, we have seen that 65% of the area is to be allotted for the cereals, and then for realizing the 10% for pulses, oil seeds 7%, and green fodder 18%. This is the component-wise profit system. Suppose where we are planting cereal, 60%, 5% profit. That is why our emphasis to the farmer is that he is getting a lot of profit from this with respect to the crops. So here in this model, I have got 15%, 10% realized 10% profit from pulses, oil seeds 7%, and green fodder 18%. Next, please. Then there's a dairy unit. We are having certain, if you see the across the country, there are certain buffaloes, there are certain cows. Here I have used the HF cross and the Mora buffalo in Gujarat, and also there's a Gir. It's giving a very good milk. There are very high yielding. If there are high yielding cattle, then we have to see that how we can reduce the greenhouse emission, that methane emission to them. We have to give them the feed which is very digestible and palatable to them, so that the gases will not be created inside the rumen, and we can reduce it. And whatever the cow dung is there, already I have told that how much of the manure is contributing. It is around about 475 that carbon dioxide equivalent gases in the gas emission we are contributing it. We have to reduce it some way. We have to put it with the recycling of the farm waste. We can use it, we can make the compost, or we can use the biogas plant we have used, and I have used here in my model, which I am going to discuss with you. And then we have to see that how much the more we are having these breeds, we have to induce into the system, so that the more profit is coming up, and then we have to accordingly rotate it. Next, please. Then we can see that this is all the waste things which are there, and then how we are going to perform a mineralize. We have made a certain formula out of it, and then how we can make the mineral bricks. And these are the small compressors, hand tool compressors. Small farmer at his level can get it. Otherwise, the cost of these compressors, if we will get, this is around about that 3 lakhs. But this is we have modernized it, and at the farmer's level, it's only costing around about 3,000 or 4,000 rupees. And then we can make these bricks and feed it to the cattle. We have made certain mineral brick formula out of the farm waste what we were having, because nothing is waste as far as the agriculture production is concerned in a farming system mode. Then we have to recycle it. Then these animals lick it, and around about 1 kg of the milk or half an kg of the milk increased with this activity. Next, please. Then poultries also, we have located an area where we can give the backyard poultry farm, where we can Van Raja is there, which is a very it can be used for the meat purposes, or it can be used for the egg laying purposes. So around there, because associated problem with the farmer with the poultry is that there's a lot of fluctuation of prices. So in order to stabilize that, when the prices are high, when the farmer should go for the poultry production, and then in a year we have given him that you go for the 5 cycles 5 times, because if it is during the rainy season, then we are saying that don't do it, because there's a losses, there's diseases are much more prevalent, and the market price, we have to see that sometimes you can see that the price of the 1 kg of poultry goes 100, 120, 130, sometimes it comes down to 80 or 85. So that is why we have to regulate with the market that which is the best time for the farmer to at least go for the 100 birds. He can put it over there for 31 days, for 41 days or 39 days. He can put it there, and then for another 41 days. So that way we have that standardized the time for him, and linked with our activities in the market, and given a ready-made solution to the farmer. You do it this way, because the time is very much important. Even not only the time in poultry, but in crop production also, time of sowing with respect to the climatic change, proper time, proper seeding, proper fertilizers. These are very non-monetary inputs. These are very much important. Although here also this is the non-monetary input, but we have standardized it. And then if it will be applied to the field, the farmer will get the more profit. Here I can see that this total profit 34,483 was an additional profit from a very small unit of land. So such things, because otherwise how the profit will increase? Once we are talking the double the farmer's income, then we have to see that the droppings of these poultry will there. This can be given to the feed to the fishes, because once we will put into the into the ponds, the plankton will develop, and that will be the ready-made feed for the fishes. Next, please. So these are the fisheries. Wherever there is the water bodies is there, we can go for the different stocks. We can put it there. Here I have put it because on the I have put surface feeder middle, and then on the top of it feeding fishes are there. Then stocking ratio, common carp, rahu, katla, mergal, and grass carp in a different ratio. We have standardized and put it, and we realized a profit of 1,77,021. It's over a period of years. This is the average. This, and then supplementary feed. It can be. It can come into the old system. Rice bran, mustard oil cake. We can put it, and the manure, which is around about 25 kg per week of the cow dung. We have to put it, and then this can give us the very good income and very sustainable income. This will not only act, because sometimes if there is a lot of rains, there is a crop failure. Then it gives an insurance to the farmer to check it, and he can have his own life. He can live a very standard life. Next, please. These are the fisheries activities which we can do at the farm, and you can see that this is the around about 9 months old fishes here, within 9 or 12 months, because constantly we are putting there, and then we are again bringing it to the market for sale and all these things. Next, please. This is the overall activity. Next, please. Then the horticulture crops. Then we have to allot a land, because I have already told that some of the land has been allotted to the farmers, standardized it. Wherever it is, we have given the mango on the periphery of this Amarpali, because it's a short-statured crop, that plant tree. Then guava on the middle of the then peaches on the dikes of the pond, lemons on the boundary, amla and amla on the boundary. So that because the income, we have to see that we have to give the round the month, round the year, every month the farmer should get the income. So that's why the planning has been made accordingly and successfully implemented in the field in the form of the research model. Next, please. Then you can see that these are the certain boundary plantations where we have acted as a biofencing, because boundary plantations, we have planted several trees where, and then in between that we have planted these, you can red one, you can see this is the Karonda, and this acts as a biofence also. And then the fruit also is coming, and it's also giving a lot of income to this. Next, please, having a very lot of medicinal value. Next, please. So then this is the production of mango and Corona on the boundary. Next, please. This you can see that guava, we can market it there. We can have a different packing materials, and then we can brand it and purchase it from the market, even from the unit of land of 1 hectare. This has been successfully given for the small farmers, this model. Next, please. So this is the vegetable also, because we have already told that why the crises are there, because we are going rice wheat. We have, if we'll allot some sort of land to these vegetables also, then you can see overall improvement, overall market we can regulate, and the farmer will not face such crisis what we are facing today. Next, please. Then mushroom unit, because we are very small, the space is required, infrastructure is required, not too much, but the technique is there. We must have the compost, and for that matter, then we have to put certain ponds. And here, once I have put it for the last 10 years, I had regularized it that when how much of that I should have these what it called that for compost material. So net return, I have realized it 18,863. Next, please. Then vermicompost, because this is the system where we can, if we have to mitigate our this nitrate oxide gases, then we have to reduce our fertilizers. For this practice, what we have done, we have made a vermicompost in pits in such a way in the first 4-tank system. This is the 4-tank system where crushed cow dung is in the first, and then after in the second tank we transfer it into the first tank, into the second tank after 15 days, because it carries a lot of microbial activities are to be carried. And then after 10-15 days we are transferring it into the first tank, and then after into the third tank, and simultaneously after 1 month, and then after 1 month and finally into the fourth tank. Wherever you can see this black that color, this is the well decomposed this vermicomposting. Worms are to be induced. For this vermicomposting, there is a technique, proper technique is to be used. We have to maintain the optimum moisture, we have to maintain the optimum temperature also. At the same time, we have to maintain the aeration also. For that, we have standardized certain techniques where all the 3 things we can do it, and we can make the faster decomposition in these things. Then vermi wash is there, and then it can be used as a, because we have to reduce the load of the pesticide into the system. That is why we can move towards the climate, that smart agriculture. So all these processes are there. Then we have to make certain equipments in such a way so that they are very sustainable and are very cheap, and we can reduce the cost of production also. For that matter, this we have developed of our own from a cycle ring, and then this is a siever. This is a rotating siever. Normally, the 4 men are required to sieve any material, but it is only the 1 person can sieve it. Such technologies we have induced and given to the farmer, and most of the farmers are doing it and earning a lot of benefit out of it. And even we can see that what we talk about the cow dung, it's a very important resource. And we have seen that in this model, having the 2 cows, we can generate around about 230 quintals of farm waste. Cow dung, as well as our all these things. As well as our citra, weeds, all these things, whatever is waste, around about 230 quintals of farm waste has been quantified. And cow dung, normally from the buffalo, we can get 60 kg per day, fresh cow dung, and 14 kg from the cow. Then we have to manage this in such a way so that we can get the maximum. Then we have to put into the vermicomposting, and then vermicomposting. Then we will reduce the load of these chemical fertilizers, and then the farmer has not to go outside his farm. Whatever the requirements from the farm needs, it is to be manufactured there in the farm and utilized into that. With this, cost of production will come down. He will realize more profit, more of the units he will be associated with it. That is how here we can see that how much the fertilizer manufacturing within the farm has been started with this some 4 composting unit on a very small land has been required for it, and the activity he is carrying, and the activity has been planned in such a way so that his 5 farmer family members can do it, so that he has not to hire from the labor. In future, we have to see that there will be a labor crisis. If the labor from Bihar and UP will not come to the rescue, what is happening in today's agriculture in Punjab and other places, because most of the farmers, they are telling that we are farmers, but actually now they are hiring these men for their farm activities. We can say that there's around about 50-60% of the farmers in Punjab and in Haryana also. I have seen it. Farming is being done by the hired laborers, mostly from Bihar, mostly from this. So in days to come, maybe that such trend will be reversed. For that matter, we should have a better equipped technology with us. So how we can increase it, how we can reduce it. So for that matter, we have also made certain efforts. And then the requirement of for this 1 hectare of this chemical fertilizer, 133, 100 kg DAP, urea 133 kg, 58 kg MOP, it has been quantified. And then we have supplemented it with our recycling waste. which are very important, that technologies have been produced, and around about 2,225 rupees per year fertilizer has been generated. And if it is in the form of the profit, you can see these around about 30,000 profit is being realized from the vermicompost itself. Next, please. Then these are the techniques. This is the farm waste. This is this we can put it. This will come as a manufacturing unit. This can come as an enterprising unit at a farmer's level if everybody is having such things, and you can go for this. Next, please. This is what I was talking about, receiving, how we have managed it and reduced the labor cost on it. Next, please. This is the biogas unit, where that whatever the cow dung is there, 25 kg cow dung is to be put into the feeding tank, and after certain time, this gas will generate over here, and this can be collected and used in this roundabout for this 2 cubic capacity. 21 LPG gas cylinders we have generated, and then around the year, no gas is to be brought outside. This is from the waste, and at the same time, we are taking care of our carbon dioxide, the pollution, greenhouse gases. Finally, we are reducing the load on our that environment, on our atmosphere. Next, please. So then small, we can see that value addition things are there. If we have planted there as this turmeric also, then it can be put it in such a way we can process it at the farm itself, and then value edit it, and then go to the market, label it, and get more price. Otherwise, we can see, we have seen that we have done it in case of rice, in case of wheat, and in case of the turmeric. We have done it at our own level, and 57%, 5% profit has been increased. Next, please. Then not only this, because you can see that how much the carbon dioxide stocking has been done with these activities, layer wise, layer after layer. We can see that in different cropping systems, how much of the carbon dioxide stocking has been there. Otherwise, this will go into the atmosphere and again make us problematic. Then again, we are talking about the climate, agriculture, resilient agriculture. These climate smart practices are to be brought in, and I have brought it for the last 10 years. And the result, which I am sharing with you, it's in front of you. In every block, how much is contributing and how much we are doing the carbon stocking at different depths of the soil level. Next, please. Next, please. Then this is because once I was talking about the greenhouse emission in the IFS model, carbon dioxide, how much each activity, what we have done, we have measured it. Each and every activity, how much of the rice, wheat, green gram, carbon dioxide, that methane emission is there, and how much we are reducing it. Normally, we have seen that total per year, carbon dioxide equivalent gas in kgs, how much we are generating? 7,070 that kgs carbon dioxide equivalent gases, which includes your carbon dioxide, methane, nitrous oxide. This we are contributing towards our atmosphere. Then what is the sink with our own our procedures? Round about 15,146 carbon dioxide equivalent gases have been sequestered, has been removed from the atmosphere, either through these that soil where we have stocked it, or in the form of the trees where we have parked it, removed from the atmosphere. If such process in each and every unit of land is there, we can mitigate the ill effects of the climate change. Because to mitigate the climatic change is not a one-day job, it is a long process. But if we can plant a model like this, have in each unit of the farmer's land, we can have so many problems, and these farming strikes, crises, suicides. This is the ready-made solution for that. Next, please. Then also micronutrients. We have not to go and get the micronutrients fertilizers, because once we are making our composting, we are recycling our back to the plowing back these composting to the field. And then we can see that how much of the zinc, copper, iron, manganese, which are very much required for the growth and development of the crop, we can generate it here, and we have quantified it after 10 years. What was our increase? It was increasing tremendously. Next, please. These are the soil fertilizers, NPK. Then initially for 3 years, we have to struggle it. What we have planned, we have not totally eliminated these chemical fertilizers from our field operations. First phase, 100% chemical fertilizers. Second phase, second year, we have gone through 50% from this till we have developed our own, because we have to give the workable solution to the farmers. A farmer cannot afford to get his production low. So 50% from this composting, farm waste, 50% from this, then 75-25, and now after 4th year, 100% of this fertilizer, organic fertilizer, he can develop of his own and flow it back to the field. Next, please. Then this is the total system. How much of the he is getting from the farm in each enterprises, and it has been quantified for the first time. And then how much he will go to the market, how much of the surpluses he's having to the market, how much of the surpluses he will use in the family, or a person who is having a 1 hectare of land. Similarly, on this basis of this, it can be extrapolated. If the land size is more, accordingly, this data can be it can be quantified over there, and then we can get our activities accordingly. So these are the percent profits. Next, please. So this is the component-wise expenditure, gross income, and net profit. We have seen normally a farmer who is doing a rice wheat cropping only, he is getting a profit of around about 80,000. But if he will diversify the way we have diversified, a quantum jump of 3 lakh, 300 is an average. 3,03,000 it can be generated by diversifying our activities, by diversifying our that planning, by diversifying our land use, and not only this, it can have added, it can mitigate the climatic change, and then we can adopt all the climate smart agriculture practices, which will bring us the sustainability and profitability to our agriculture system. Next, please. So this is the percentage share profit under different farm enterprises. Dairying is because it's having a milk, it's having this cow dung, and then biogas unit. Around about 48% is coming, realizing profit from this dairying. This is the most important. Then followed by crops, foders, and then horticulture crop, around about 14%. That horticulture, 38%. Fisheries and poultry, mushroom. So this is how the profit we can realize, and then that's how we can increase. Normally, if the farmer will do his activities only rice wheat, he will plant only 80 lakh or 85 lakh, 85,000 he can get it. Now, if we will do our activities in this, it can 3 times increases there. So, next, please. So this is how now, not only this has been planned in such a way so that in every month he can realize a profit. July, August, September, October. Now, otherwise he has to wait for the crop season. Once the rice will come, then he can get the money. Once wheat he will harvest, then he can get the money. So by this land use planning is having another important advantage, wherever he can get the profit of every month. How much of the profit he will get in July, and then the employment generation. Because if he is having 1 hectare, if there is a rice, he need around about 25% at a stretch for transplanting. Here he is having a limited area of the land, and the 2 operations of land and the vegetable are not that overlapping with each other. That way he can utilize his 5 farmers family in each and every. He has not to hire any farm labor. This is the another ready-made solution which we have given to the farmers by way of our experimentation. Next, please. So this is the year-wise profit without depreciation value. Somebody has go to the bankable model. They can have the entrepreneurship. Now this time we are telling that Atmanirbhar Bharat, even banks can give into the modern NABARD bank. We have given it, and they are also now telling that youths to come up and then get funds, get government loans for that, and develop a model like this so that you will become really an Atmanirbhar Bharat. Next, please. These are the very silent features which I have already talked about you. Next, please. Thank you very much. These are the medals and awards I had got for my work, which I have done throughout my career, and lot many things has been done. Thank you very much.
Thank you. Thank you very much, Dr. Kachru. It was an enlightening lecture on integrated farm systems and land use planning. I have a just query.
Yeah.
Whether any work on biodynamic preparations have been carried out?
Yeah. This is a part of that. This is a part of that. Yeah.
But we didn't see any slide on that.
Actually, what we did, whatever the composting is there. Once we are talking about the enrichment, so enriched, we had made certain formulations wherever different what we can see that these microorganisms and the vermicomposting, a process have been made in such a consortium mode so that it will enrich, the nutrient content will increase in the composting, as well as there will be the faster rate of degradation, that faster rate of decomposition. So that very much we have done it. That is in the very capsule form. We have already made it as a consortium mode. It's already there.
Because where do we go for organic farming? We have to. There has no role of chemical fertilizers or.
That is what actually what I can advocate from my own experience. Because if we will tell a farmer abruptly switch on to the organic farming, the yield is first. Yeah.
Slowly.
Slowly.
Yes, but
he will slowly. He has to first develop the infrastructure. He has to first generate a mechanism wherever he will get his own composting for replacement of these chemical fertilizers.
You see, in 1924, Rudolf Steiner, he invented this biodynamic framework, where biodynamic preparations like BD 500, cow horn manure, cow horn silica, and BD 504, stinging nettle, biodynamic 505, oak bark. These all preparations are being made.
Actually, there are a lot many. There are Panchgavya. There are Panchgavya. Yes. I had also made certain things, but finally, because the problem is there, once lot many formulation, even in the market also is there, but it's not working in the field.
Right.
What we are saying that once we are making a composting, we have to enrich our composting in such a way, and that is practically working. Suppose now if I had a different formulation, Panchgavya or in horns, what you are telling, there are so many Amrit Amrit Pani formulations, urine fermentation, so many things are coming up. But what we have devised, we have made once decomposing of our waste, we have used all these things in a proportion. Even a urine also we have recycled in a composting, and then it helps in the increasing the microbial population. And then it also we have induced certain trichobaridium also. And then what is the time for the trichobaridium? Because we have seen that if we have put in our composting trichobaridium, earthworms got a problem. So finally, at the later stages, we have put it before 10 days of that the compost is there or sieving. We have done it, and then we have placed it. Similarly, vermiwash also. With the vermiwash, what is there? We have put the water, but here we have exercised with the cow urine and 50% with cow urine, 50% with water, and then we were putting these. And then once the vermiwash was, and then we were getting it, and then 1% solution we used to separate. So this is how the things have been formulated, and this have worked also.
Yeah, certainly. Oh, well, thank you, Dr. Kachru. for your lecture on integrated farming system and land use pattern.
Thank you
Now
very much.
I just hand over the session to Dr. MP Gautam, sir. Dr. Gautam, please.
Okay. So first of all, I would like to congratulate Professor Dr. Vijay Kumar and Dr. Tilip Kachru for their excellent and informative lectures. Dr. Radhan is very knowledgeable pathologist. In his lecture, he has tried to explain various aspects and growing concern related to plant pathology, like agriculture productivity and increasing demand, effect of climate and plant diseases, and their adverse effect on crops. In his way, he tried to explain disease management, especially the monitoring of plant pathogens and prevention regarding entry of pathogens in crops. He also highlighted the use of chemical, pesticide, and their adverse effect. He also discussed the IDM method. And lastly, he has also advised and given suggestions regarding the improvement of the productivity. So thank you very much. He has given a very good lecture. As far as our second speaker is concerned, Professor Dr. Tilip Kachru. He is well-known figure in agronomy. Congratulations for your valuable talk. You have discussed about the challenges in agriculture in India, concepts of land use and planning. He also explained very nicely CSA, means the climate smart agriculture practices. Regarding the conservation technologies, effect on agriculture due to climate changes and different types of environment factors. Dr. Kachru has also discussed about the horticulture, livestock, fisheries, poultry, vermicompost, biogas units, and soil fertilizers. So both the lectures were very informative, and I congratulate both the lectures. Thank you very much.
Thank you very much, sir. Now it's over to you, Dr. Shinde.
Yes, sir. Thank you. Thank you very much. Good evening, everyone, to all speakers and co-chairpersons. I'm here to present, lastly, to vote of thanks for today's symposium on sustainable agriculture under Sanmantrana 2021. I would like to thank our speakers, Dr. Vijay Kumar and Dr. Tilip Kachru, sir, for joining online and enlightening us with their knowledge in Sanmantrana 2021, a multidisciplinary international congress on good practices and capacity building for sustainable development goals. Today's session was full of knowledge and wisdom. Dr. Vijay Kumar told us about integrated disease management, a step towards sustainable agriculture. And Dr. Tilip Kachru sir presented on topic land use planning, farming system perspective towards climate smart agriculture, profitability, livelihood, security of small farm holdings were really informative. I am pretty sure the knowledge that Dr. Vijay Kumar and Dr. Tilip Kachru gave us will definitely help us in our understanding of sustainable agriculture. Once again, I would like to thank you, our speakers, Dr. Vijay Kumar sir and Dr. Tilip Kachru sir, for taking out time from their busy schedule and enlightening us with the knowledge. Thank you so much. I would like to like to thank you, our session chairperson, Professor Vinod Dhar sir, and co-chairperson, Dr. MP Gautam sir, and also coordinator of Sri Vaishnav Institute of Agriculture, Dr. K.N. Guruprasad sir, for organizing and conducting this session. Thank you. Thank you to all the participants for paying your attention for learning. Thank you. I declare now the close of the session. Thank you.
Thank you.
Thank you very much.
Thank you. Thank you.
Thank you, Dr. Razdan. Thank you, Dr.
Thank you.
Kachru.
Thank you,
very much.
sir.
Thank you for that.
राजस्थान कचरू सर आपने मतलब बहुत अच्छी तरह से हमको समझा दिया, बहुत बढ़िया। और आपने इतनी जम्मू कश्मीर से भी इतने नेटवर्क कनेक्शन होने के बावजूद भी आपने अच्छा रिप्रेजेंट किया। बहुत एग्रीकल्चर की तरफ से हम सबका धन्यवाद अदा करते हैं।
Thank you very much.
Yeah.
Thanks, Dr. Dar, for the opportunity that you have given to us for participating in this.
Welcome. You are welcome, sir. Always.
Really, thank you. Thank you very much. It's very nice to interact